Hi, I'm Lynn Langett. Welcome to part 5 of my 5-part series on understanding Hadoop MapReduce fundamentals. In this section of the course, we're going to talk about what types of problems MapReduce is not suited to work with and some of the alternatives to MapReduce for large-scale distributed processing on big data. So let's first review and cover the sets of problems or the problem types that MapReduce is in its current state does not adequately address. First of all, one of the big limiters in working with MapReduce for certain types of data processing is that it is a batch-based algorithm. There are continual optimizations coming around the algorithm and the ecosystem and the various distributions, and they're really exciting to watch. And I'll be talking about a specific area actually in this module. But the current state of affairs is that MapReduce is batch processing and it runs substantially slower than interactive data processing. So most commonly, MapReduce is used at some stage, usually an earlier stage, in an ETL pipeline that has some type of interactive exploration of the aggregated output at a later stage, which is not performed by MapReduce. So adding MapReduce is not a replacement, it's an augmentation for the sort of traditional data warehouse stores. Secondly, the MapReduce algorithm and the underlying storage mechanism of HDFS were designed out of work done at Google to address a specific domain problem, and that was indexing the content of the web. So this is a problem set that is, again, a subset of the various big data problems that present themselves in this world of data that is of varying variety, velocity, and volume. So you see it as part of the big data toolkit rather than a all-encompassing solution. In particular, it is quite new for developers who work in the object-oriented paradigm to adjust and learn and be comfortable working in the functional paradigm that MapReduce is designed to be executed using. Ancillary to that, in addition to a lack of developer skill available, there's also a lack of administrators. An anecdotal story I'll tell you is when I took a class from one of the major Hadoop vendors, there was a person in the class who had been forced to become a Hadoop administrator because the company he was working at decided to go with Hadoop, and literally he took the class because the cluster was not reliable and it was going down, and he was doing support from the class as he learned new aspects of cluster management. So there is a lack of trained DBAs, if you will, that understand how to set up and support and maintain and tune both the hardware and the software configuration that is a Hadoop cluster. And finally, the API and the security model are moving targets. Since I've been working with the product, the API has had one major release. There's also the plethora of libraries and tools that seems to be updating on nearly a monthly basis. So it's very, very challenging because it's a very young ecosystem and not a mature ecosystem. So there's significant cost involved in bringing Hadoop projects in terms of training, developer support, admin support, understanding which tooling, which API, and all these costs have to be carefully considered when determining whether or not MapReduce and Hadoop are appropriate solutions for your particular big data situation. Another useful comparison I found, particularly when I'm working with C-level executives who are grappling to understand the usefulness of the Hadoop ecosystem, is this chart that which compares relational database systems versus Hadoop capabilities. Very, very simple and straightforward. The first consideration in terms of selection is the size of data. If you don't have data that is in the many, many terabytes, it really doesn't generally make sense to go with a Hadoop implementation. You may want to go with a NoSQL solution such as MongoDB or some of the other lightweight databases such as Cassandra, or one of the many other NoSQL databases. But to move from relational directly into Hadoop, one of the big drivers is the volume of data. So it should be in the many terabytes to the petabytes. The access we've talked about extensively. Hadoop currently is batch. Updates, of course, Hadoop information is write once, read many times. A traditional database is read, write many times. Hadoop and MapReduce really has no schema unless you use HBase, which most people do, so that they can get the Hive implementation, but the HDFS itself does not impose a schema on the incoming data. There is, of course, no transactional integrity. It's often called base rather than ACID, so it's eventually consistent rather than transactionally consistent. The scaling, though, is one of the reasons that you would choose MapReduce with a high volume of data, because the scaling is designed to be linear. And as I mentioned when we were in the tuning MapReduce section, a very common situation is to start a big data project with a relatively small Hadoop cluster with some anticipation of a very, very huge amount of data coming into the project, and then just planning to scale out by adding lots and lots of nodes. And we've talked really ad nauseum about the query response time. Given the limitations in the current Hadoop ecosystem, are there alternatives? And just for comparison point, I'll pick a vendor, I'll pick Microsoft, and talk about some of the alternatives that I've worked with customers who are on the Microsoft platform and really wish to stay there. So when we discuss big data projects, we look at volume, variety, and velocity. And we will first work with their existing relational system. I've had many customers for whom their quote-unquote big data solution was simply to upgrade the version of SQL Server that they had so that they could scale using their relational system. So that in many cases is a good choice depending on the different input values that I talked about. Of course, you also have the opportunity to scale via cloud, with both relational storage with SQL Azure, or now Windows Azure VMs with SQL Server 2012 running on them, or moving part of your data into non-relational storage such as Azure Tables or Azure Blobs. SQL Server itself, of course, has many scalable additions all the way up to the PDW. Another implementation that I've worked with my customers in the Microsoft stack is to utilize some of the new in-memory OLAP type features offered through analysis services. I've had many customers try out the new tabular models, which is Power Pivot on a server, and it is in fact a type of a NoSQL solution. It's an in-memory columnar database that scales very, very broadly, and it's very simple to implement if you are on the Microsoft stack. And that's been a very good solution for some of my what I call small big data projects. In addition to that, Microsoft is doing some interesting work. They announced last year at the SQL Pass Summit that they're working on something called Polybase, which is a combination of HDFS and a database with two types of query engines. And you may remember this because this is basically identical to the diagram that I first showed in this course, talking about the dream of ANSI SQL queries on Hadoop scale data. Now it remains to be seen, what and when they will deliver. From what I understand, this is currently a private invite-only beta. I have not seen any of the work. I am following it though with great interest because they, like many other vendors, are trying to build what all of us are wanting, which is some kind of SQL on either of these stores, along with MapReduce when we have that particular use. Now I'm using the word Dremel here when I talk about Polybase, and I'll be expanding on that as we go into the next slide. So Google, of course, is the originator of the technology upon which Hadoop and MapReduce is built. And so you may wonder, what is it that Google is doing to extend and expand the platform? Well, indeed, they've done quite a lot. They have created a new type of execution engine which works in a more interactive kind of a way. And they have also released white papers about the technology, which they call Dremel. Now, once that white paper was released, then the open source community started an implementation which is called the Apache Drill project. So what this is, as you can see, It's a distributed data system for interactive, rather than batch, analysis of large-scale data sets based on Google Dremel. Its goal is to efficiently process nested data. I mentioned this very briefly, but one of the limitations of MapReduce is that it handles join type queries very, very poorly. It can be done, and I have seen implementations, but again, I purposely didn't focus on it in this course because it's an introductory course. That's an advanced technique, and more often than not, people get it wrong than right. Basically, when you first start, you want to avoid it. So for drill, they want to have Hadoop scale data, interactive query, and be able to process nested data. So it's a design goal to scale 10,000 servers or more and be able to process petabytes of data and trillions of records in seconds. And from their white paper, you can see I've copied out a graphic here that compares execution time between traditional MapReduce and Dremel. And you can see Dremel is exponentially faster. So Google doesn't release internal details about its own implementations of Dremel, but of course the open source work is quite well documented. So this is a diagram from the Apache drill project, which shows in fact the two types of query parsers against the underlying execution engine, which would of course go against the underlying data. So the dream of both ANSI SQL and MapReduce style paradigm going against massive data stores is being worked on very, very actively in the Hadoop community. In fact, there are two in-market alternatives already commercially available, and I encourage you as part of your learning about the Hadoop ecosystem to explore these newly released products. So literally when I was making this course, Cloudera added to their distribution of Hadoop their version of Apache drill, which is called Impala. This was initially released in a preview edition last November. Great excitement in the Hadoop community because of course the dream is to have this interactive SQL-like query on Hadoop scale data, and this is what so many vendors are working towards. So you can see this is a very well done diagram where they have the Impala component and they have the batch processing component shown with MapReduce, Hive, and Pig, and the machine learning component with Mahout and some other type of library there running against the massive scale of storage. Now Cloudera's new downloadable virtual machine does include an Impala distribution, so I encourage you to do direct comparisons between Hive execution and Impala because they both use ANSI SQL-like statements. Now it's not ANSI SQL, but it's similar, and you can see the differences in the execution and the processing. It's very, very dramatic. Of course, Google, the inventor of this technology, also has a product in market. It's part of their cloud offering, and it's deceptively simple. In fact, to me, it's one of the most exciting products that I've seen released into this ecosystem in the past year. So exciting that I actually created a completely separate course on Pluralsight about BigQuery, and I've actually worked with it with customers. Because it's such an interesting product, I want to take the time in this course to show it to you. Now there's many ways that you can work with BigQuery. It's basically Dremel as a service. The simplest possible initial exploration is to sign up for a Google account. They have a generous free tier, create a cloud-based project, and to use the web console to try out some interactive queries with their subset of ANSI-like SQL against massive amounts of data. Again, it's deceptively simple. It looks like you just type in a query and you're on some sort of SQL Server-like environment, but it's important to understand that the underlying architecture is completely different and based on Google scale size of data. So this is a very, very interesting implementation for you to also evaluate. In this presentation, I'm going to show you a little bit about some future directions around big data technologies that do impact Hadoop and MapReduce. Specifically, I want to talk a bit about Apache drill, So you'll see here from Wikipedia that Drill, as I mentioned in the lecture, is an open source framework that supports data-intensive distributed apps for, here's the important word, interactive analysis rather than batch-based analysis of large-scale data sets. It's the open source version of Google's Dremel system, which again I mentioned in the lecture, and I recommend that you read the white paper on it that's referenced in the notes, and is available as infrastructure as a service called BigQuery. So the idea is that Drill is able to scale to 10,000 servers or more and be able to process petabytes of data and trillions of records in seconds using a SQL-like interface. So as mentioned, Cloudera has an implementation of this in CDH4 called Impala, which I recommend you also take a look at. But for the purposes of demonstration, we're going to go over to Google's cloud-based implementation. So to get there, you go to developers.google.com and scroll down to the API console. Now I've actually created an entire separate course for Pluralsight on BigQuery. So if you are interested, I recommend that you take a look. So I've set up a cloud-based project which includes access to the BigQuery API. And I'm just going to show you one type of interface to it, which is the web interface, just to give you a sense of what it looks like. So you can see inside of BigQuery, you have the ability to work with queries and work with jobs. So jobs, of course, we understand from MapReduce is the processing of the particular query. The difference is that it's using a different type of access here. So if I look at my various data sets, which are stored up on Google's cloud, and is a significant limitation with this implementation of Dremel or Drill, then I click and go into some of these queries. Let me just pick something here. Let's say, well actually I'll show you a data set first. So I'll go into the public data samples and I'll show you a sample around Wikipedia. And you can see this is a Wikipedia sample. Here's the schema, and then I can run a query against that. So I'll just take some of these queries that I have sitting here already. So let me pick one here, and then you can see that it's a very SQL-like syntax. But the difference is it runs on Google's infrastructure very, very quickly. And you can see 9 gigs of data processed in 3 seconds, almost 4, and I can download this as CSV or save as a table. So there's a lot more to this service than what I'm previewing right here, but one of the important points is whether you look at Google's implementation or some implementation that is based on the open source work, you know, whether it's Cloudera or something else, when you are considering using a distributed type of processing solution because the volume of data, you should be aware of these new technologies as well. So that's a window into an implementation of Google Dremel, which is called Google BigQuery. At this point in the class, you have got a very solid foundation in the Hadoop MapReduce programming paradigm. If I've reached my goal, then you have a list of to-dos because the ecosystem itself is quite complex, and depending on which path you want to take to work with Hadoop, you'll have more studying to do. So there are a couple of takeaways that I hope that you can start with when you're making your action list. The first takeaway is to understand what classes of problems Hadoop and MapReduce are best suited to solve. It's very important to use the right data tool for the job, and in this evolving big data market, it's really challenging to figure out what type of storage, what type of processing, and I hope that I've added to your knowledge store with this course. If you do choose to write MapReduce queries, I encourage you to learn more about writing MapReduce. It's quite a complex topic. I actually have spent about 10 days in classrooms and still feel like, even though I've worked with customers and written prototypes, it just takes writing over and over and over to get comfortable with this new paradigm. So I encourage you to get as much sample code, write as much as you can, and just practice, practice, practice. There's really no other way to get this new data manipulation paradigm under your belt. Once you've got the basics down, then you're going to move into the optimizations. I really covered them very lightly in this class, so I'll emphasize that first you want to get the appropriate MapReduce programming paradigm, which is functional, simple, key value in, key value out, one MapReduce job for one type of transformation, chain jobs, use all your various data pre-processing, so on and so forth, and then you can go and look at your optimization, including and always remembering that a very simple optimization is to add more nodes to your cluster. I also wanted to give you information about Hadoop alternatives and futures because it's very important to understand that this is a very young ecosystem, and if you're going to jump on this boat, you're going to go very, very quickly down the river, and it's important that you understand what new tools, what new vendors, what new frameworks are available. It's really an exciting time to be working with big data because of the velocity of change in the Hadoop ecosystem. So I've pulled together just a short list of resources that I found to be really helpful. I would go through the core MapReduce tutorial on the Apache site, which I referenced here. I also encourage you to take a look at Cloudera's offerings. They're putting more and more online content, and I highly recommend their 4-day developer course. I've actually gone through it twice because of the change in the MapReduce API, and I've taken their certification exam, and studying for that really helped me to get a deeper understanding of MapReduce that I find useful really day in and day out. I haven't spent as much time looking at the other vendors' education resources, but the major vendors are Hortonworks and MapR. In addition to that, there's some good tutorials on the AWS site, and I've gone through pretty much every tutorial on the Windows Azure HD Insight site, and they are also pretty well written. So those are some great ways to start if you want to do even more than what you've seen in this class. So I'll leave you with my high-level view of the world of data. There will always be a place for the RDBMS. It's not going away, it's not being replaced, but the elephant is a part of our world. As more and more data becomes available for us for both personal and business use, solutions like Hadoop are part of the data landscape. Also, many other services are going to help us to make good use of that data, whether they're tools, frameworks, visualizations, libraries. Very, very important. The data landscape is far beyond your RDBMS. Thanks for listening.